Today, we're going to talk about reverbs and what makes them tick. Hey, I'm Yoad. Welcome to my studio. Reverbs shouldn't be mysterious at all. It's just a bunch of delays. If you think about a person clapping in front of a wall, you'll get a reflection from here, from the entire surface of the wall. These reflections will be mixed and merged together, creating dispersion. So you will not get a single discrete reflection. You will get the sum of all those reflections, which will be smeared. The transients will be kind of meshed up together. So you'll get something which is not coherent. It will be dispersed. Now, if you add another wall, then you'll get the same reflections or similar, depending on the surface of the wall. But then the reflections coming from here will also get deflected by this wall, the ceiling, the floor, and all that. So very quickly, you get something which is very, very complex. But it's actually a bunch of reflections. In digital reverbs, we try to emulate this behavior. I'm going to start with a very simple delay. So we're going to have a very distinct reflection or repeat. Now, if I add another one, and another one, and so forth. Now, if I use feedback, meaning that I'm going to send all these reflections or repeats back to the input, what I'm going to get is something which is very resonant and kind of metallic. Quite unpleasant. Now, if I want to arrange the delays in a more random sequence, something like that, and the feedback as well. So this is going to be a bit less predictable. So already I'm getting something which is a little bit more complex. Now, if I duplicate this delay and rearrange the repeats in another way, which is also random. Well, now I have an even more complex pattern, which sounds more dense. Now let's see what happens if I send the first delay to the second delay. And then I send the second delay back to the first delay. I have to be very careful because this can very quickly get out of control. But you get the idea. In order to prevent the feedback getting out of control in an infinite loop, what I can do is modulate the signal before going to the delay. And that will sound something like that. So if I have this vocal here, and I modulate the frequency, I get something like that, which will make it harder for the feedback to build on itself in a loop that gets out of control. So let's hear that in action. So now that modulation is going to feed the delay. So already it's sounding a little bit more rich, more interesting, and I'm going to replicate that on the other channel as well. And now I'm going to feed the first delay line back to the second. So now I'm getting something which is not a reverb, but it's not really a delay anymore. And the other way to make it more rich, more dispersed, and more reverb-like is to add early reflections before sending the signal to the delay line. So let's hear how very basic early reflections sound. So there's still a bunch of discrete delay repeats, but they're dispersed by using all-pass filters and other means of smearing the transients. Now this is very resonant because they're equally distant. If I use a more random pattern, I get something like that. And I can use different patterns. So if we listen to it now, we get something that is starting to sound more like reverb. If I take this original signal out of the mix bus and we hear just the auxiliary returns, it sounds pretty convincing. It's a little bit out of control because we have a lot of feedback, which we can decrease a little bit. We can still hear the pattern it creates, but this is a very, very primitive way of demonstrating how a reverb works. If you enjoy my videos, you may want to consider subscribing to this channel because it encourages me to make more. Now, if we ignore all that, go back to our source track, and then I can load a very old reverb, which is this one. And here we can really strip it down. So if we go and listen just to the early reflections, we can hear the dispersion. And the room size basically manifests in the space or the delay time between each discrete reflection. Now, if I listen to the reverb, now remember the early reflections feed the other delay line, which creates the reverb, which has more diffusion because it uses more all-pass filters. So if I strip it back, I get just dispersed reflections. If I add the density control means that I'm feeding the delay lines back on themselves. So without it, it sounds quite discrete. And the diffusion means that I use panning in the process. And now I'm getting something that already sounds like a reverb. Not a very high quality one, but it's not too bad. And again, I can strip it down back to very discrete, unpleasant, predictable reflections or repeats. Now, if we dial a more rich and usable reverb and add back some of the early reflection source so we can actually hear them, which places the vocal in a room, and then we have the kind of inter reflections. Let's listen to this drum loop. Now, in practice, if we want to add reverb to any source, it will make it sound distant. And in order to deal with that, we can use pre-delay. So without pre-delay, the drums sound like they're in a large room somewhere in the distance. But if we want it to work in a mix, we want to be able to hear the source close and then add the reverb. So we're going to introduce something which doesn't occur in acoustic spaces, which is pre-delay. So now I'm going to basically delay all the processing, all these delay lines and feedback and all that. I'm going to make it happen after a certain amount of time. In this case, 90 milliseconds. So now what happens is that I'm hearing the drums first, and then I'm hearing the tail. Let's compare. Without, the drums themselves sound like they're in the distance. And here, I'm getting a distinct tail, which is artificial, but this is something we use a lot in mixing. So obviously, for this type of part, this is way too long, way too wet. But if I use it in moderation, it gives it space. Now I can also control the behavior of certain frequency ranges over time, which means if you remember the feedback loop we created, if I add a filter inside that feedback loop, so every time it will feed back, it will, if it's a low-pass filter, it will lose more and more highs. And this is what damping filter is. If we switch to a more classic reverb, now I control the behavior of the high frequencies. By controlling the filtering I introduce within the feedback line. So most acoustic surfaces will have some sort of damping. So that makes it sound more natural. Now, since we can manipulate the early reflection delay taps, we can achieve sounds which are acoustically not possible. So if we go for a gated shape, it means that all the reflections will have the same level, and then the last one will just stop and the whole thing will sound gated. And with diffusion, or we can go for a non-linear. Now here, each reflection has its own feedback loop on itself with dispersion filters. Now when we feed that into the reverb, we get reverb tones which are not realistic, but they serve a great purpose in production and mixing. Again, I want to use pre-delay, and I can make it musical. So it's almost like another part. And then I can play with different properties of the delays. So emphasizing the swing of this part. Let's try another signal. So I can place the signal in many spaces very easily. Or I can make it almost sound like it's in a barrel or something. And from there, I can really be very flexible. Now, in most algorithmic reverbs, when you change the size parameter, you will hear this kind of zipper noise. Let's mute the reverb and go for just a wet signal. And that happens because we recalculate, if we look at the early reflections, when we change the size, we recalculate the delay line timing. So we have to reset the memory every time. So we're restarting the signal, and that results in clicking. And when they get fed into the reverb, we get that effect. We can change other parameters smoothly, like the decay time, which is the feedback, because we're just changing gains. This video is turning to be too long. I want to cover more reverb types, but we'll do it on another video. If you like this video, you know what to do, and I will see you on the next one.